So one of the things just before Yagwa starts that was emphasized in the ASEG meeting that was just over the last 3 days is we need to be an industry that innovates. And of course, part of the thing about the nice part of the ASEG is you actually have people from the oil industry, oil and gas industry, unconventional industry, sitting in the same conference at least. You may have your separate solitudes, but at least when the drinky sessions and the rest of it, we do get to talk with these guys in suits if we want to, and look at some of the technologies they're using. And this is in that spirit. There's been a very interesting program that the oil and gas industry has been supporting successfully. I know that started in 2007, but I'm sure the idea building and the conversations at conferences like this probably go back 3 or 4 years before that, conceptually, and there are probably some experiments in this. But Yagwa is a director of the SEAM project now, and we've been having some discussions, including we got a small meeting together at the PDAC last March to see if whether there couldn't be some sort of application of this technology in the minerals industry. So this is kind of a left lateral step from the point of view of most of what I see the minerals industry working on, but it's something that if we saw there were value as we work more undercover and trying to conceptualize our geology and geophysics into a common earth model, then the SEAM approach might have value. So Yagwa's going to give a short introduction. I've got a few slides, and we basically we can wrap up the morning session with that. Have any comments about that talk, and then head for lunch. So with that, Yagwa, take her away.
Thanks, Ken. And before I start, I also want to thank Ken for his enthusiasm and also seeing the opportunity for possible connection between mining community and the seismic side of SEG, that's Society of Exploration Geophysicists. And so basically for this presentation, I'm actually putting on an entirely different hat, taking out my academic and my own consortium hat, so that's out of picture. As Ken mentioned, that I'm actually volunteering on the board of directors for the SEAM Corporation, what I'll do is I'll run through that. And I also want to mention a bit of background is that this whole initiative on the mineral-related SEAM project, or this discussion, was actually initiated by Ken when he saw a presentation, one of the IQ conferences run by ASEG and SOS Connection. So he's been spearheading the discussion. And now we got to the point that discussion is very much on the agenda of the board. It's one of the several possible directions that the SEAM is taking. So what happens on the SEAM board, some of us with different connections background take on different areas trying to get the something going, and we're uncertain right now what will be happening. But mineral related one is definitely on the book. Hopefully with the input of community, especially as I go, probably with support from the major mining companies, we might be able to make this happen. If not entire phase 3 of the SEAM, but part of the phase 3. So the okay, so what's happening here? Well, let's go through just. So the SEAM stands for SEG Advanced Modeling Corporation, and it's a non-profit corporation run under SEG. So happens there are several non-profit corporations under SEG, mostly meant to serve the community. And it started as one that, as conventions for the seismic and petroleum exploration. So the description you'll notice is you'll find it on the webpage at Resource and Research SEAM. This is original description, so nothing has been changed in terms of mandate of the corporation, but that's not to say it's not going to change. In fact, the whole consensus is now to move beyond the seismic. I will not go through details on this one. So the motivation is really, I think this is really in line with what we're talking about here, is the provides data sets, test algorithms, and for imaging and inversion. And one of the other aspects that's been discussed quite a bit right now is how to actually provide a data set framework to educate next generation of geophysicists, which I heard a lot of discussion in the mining community. It's equally happening in the petroleum side. So the whole idea is put this model together, and you do the modeling, and then distribute model data and understand how to interpret this data, or what are the artifacts of particular algorithm, which actually has been something that we've been discussing or hearing a lot in this conference. And this one, as mentioned, that's kind of coming in, become more and more important. So the SIM cooperation happens basically, it's got board of directors, bunch of volunteers who has nothing else to do, and just have a monthly board meeting or by a teleconference, and we actually each organization or individual, in fact, pay the expenses if we go to the meetings. And then under there, we have the technical committees, different ones. These are all volunteers from sponsoring companies and from industry. Then within that, we have a small, very small paid staff, which actually is partly associated with ASEG, partly is covered by the funds in the SIM Corporation. Then usually for each project, which would be equivalent to each phase, and we hire project managers. These are basically part-time employee of the corporation. And on this, right now, there are two concurrent projects, phase 1 and phase 2. Phase 1 is primarily marine seismic. Comes down to the base of salt, subsalt imaging. That's one of the classical problems in petroleum exploration. Then phase 2 is underway. Right now, it's basically moving from marine setting to the land seismic. Now, the phase 2 is in the middle, and so therefore we're looking towards what to do in terms of phase 3 and generate ideas and get the support and comment. Put everything together. As Ken mentioned, my understanding is that initially, before the SIM was formed, that just people were talking and put this thing together. Initially, over half a year period, it was extremely difficult. And there's a vision that was followed through, but it was very difficult to get things going. In the end, what transpired was the companies put the resources together, put the knowledge, data together, build these models. That turned out to be the crown jewel of the whole effort. Although most of the discussion now is to talk about data, but turned out that's the model that's built by the whole corporation. Really, it's the companies, sponsors who actually chipped in. That's most valuable. I can see that parallel happening in mineral industry as well. So these are the board of directors. You notice that primarily these are all from the petroleum industry, and they're two academics, Maniktoni and myself. And so the reason this is happening is that currently it's dominated by petroleum, but this could change. Every year there's turnover and new nominations, just adapting to the need of the corporation. As I mentioned, everyone is volunteering on that. So quickly for the phase 1, it's subsalt imaging. So that's completed. As I mentioned, they basically large number of majors in the petroleum industry put in their knowledge and manpower to build this model. Then the biggest part is actually in terms of computation is having vendors to do this simulation. So that actually brings us to another part of this is, I'll leave this there, talk a little bit about the funding mechanism. It's like consortium, but in a unique way. And the whole idea is not to generate any profit. Funding comes in, the SIM also goes after money from government agencies. Then all that money, a small portion goes to fund the staff, the project managers. The entire rest of the budget goes to contract out work. Basically, for each task in this project, this bid sent out to the community. Then companies will submit bid. It's blind evaluation process. Then whoever wins that goes to do the task. So that's how it operates. So phase 1, as mentioned, is the subsoil imaging, marine setting. Phase 2 is underway. It's land seismic. So it's kind of natural progression of what's going on. So these are the current sponsors. Phase 1 also had a fair amount of money from REPSI, that's a U.S. government agency for energy security. And so this is current one. And what I want to mention is, I can't just skip this one. interest of time. This might be, compared to the phase one, this is a lot more, the methodology is a lot more relevant to mineral industry, because in the land seismic, there's a variety of challenges. There isn't a single model that kind of fits the need of entire spectrum. So in this case, there are 4 models built, and there's arid foothills, unconventional thrust. And I can see this as quite parallel to what we might need if we ever put together a mineral exploration related SEAM project, because we have variety, different needs, fairly diverse scenarios. So the way this is an older slide, but actually shows what summarizes the process. So decide on these models, and then none of this is predetermined. The model is built up, including structure, what type of model you're going to build. It's all part of the approach. As I mentioned, part of that model building, the process is done by vendors, but the conceptual part, some of the major data that's provided that goes into the structure of the model, it's all coming from the sponsors. And in the end, you basically comes down to your rock physics or the reservoir parameters, how to translate those into the physical property data. So this is also parallel to what might happen in the mineral industry. We deal with petrophysical data, conductivity, velocity, and density, but that actually is not really living in vacuum. It actually has something to do with the geological model, the system we're doing the exploration in. So that's the that slide, and then comes down to the phase 3 possibility. As I mentioned, there are other ones I can mention. One of them is the 4D monitoring of petroleum reservoir. Another is pore pressure prediction. And because of Ken's initiative, and actually brought this to the board, and that also fits in with the kind of changing view of the ASEG. Trying to, ASEG is putting a lot more effort to serve beyond the petroleum and seismic community. So in that context, especially also this near surface merging. So they think in terms of timing fits in really well. There's broad support within the ASEG and within the SEAM. I think we just need to get enough support from the mining community. So all these upon questions, this is a slide we actually discussed in the Toronto. All these are actually pulled down as just something to prompt discussion. We're not saying that this is necessarily the way to go. And one thing that might be important that's discussed a lot is to leverage on the synergy between the seismic and non-seismic community, which at the highest level would really mostly mean mineral and petroleum exploration. As we go down in depth and more details, a lot more data interaction, but that's what actually might be happening. Now, of course, one big question is, do we really have a good funding base in the mineral industry? That's key. And the possible different possibilities that we could actually take a approach similar to phase 1 or phase 2, just very focused, set up the type of model, type of problem we can solve, and go after that. Another possibility is actually do modular approach. You identify a whole bunch of smaller sets of problems, put this together, and solicit funding individually, and eventually somehow deliver and / market this smaller package to the community. And the other part that's been discussed now is, by the way, here the near surface means something a bit broader, and for the seismic or petroleum industry, is really one of the areas talking about the near surface geohazard in terms of drilling and also improving seismic imaging. And this actually might be a really good overlapping area for bringing mineral exploration and petroleum exploration production together. And other similar kind of discussions happening. So that's pretty much what I have. Oh, what's going on for this one? And this is just kind of from discussion came out of the Toronto discussion, basically deposit system for specific types, or look at the entire footprint, or can we look at some kind of typical porphyry system on different scales and build up enough complexity so that we can actually test and evaluate. And now this one is the current discussion, and there's a lot of debate about what steps, whether it's uncovered, but the whole concept is, difficult, challenging areas for mineral exploration. What can some modeling project can be put together that will help with the science and technology. With that, I'll stop there, and both Ken and I can answer questions on this. So in closing, basically, what we're looking at two things. One is whether there is an interest and feasibility in the mineral industry to put this together. Ultimately, it's about serving the mineral exploration industry. It's not about the ASEG, because ASEG SEAM doesn't actually, once the project is done, the SEAM and ASEG doesn't actually gain anything. It's just this stuff and sits there and it's available for the community somehow. So that's why it's a bit different from university consortium. There, you're really looking for funded to sustain the organization, go on to support student, even faculty some salary. But this is really trying to come up with mechanism to serve the community. And the other part is this is a funding base. Are there enough willingness and support to get something like this going? So with that, we can probably have a quick discussion or have your...
Thanks, well, as Yago indicated, SEAM is out there. It's in the oil and gas business. The reason I think I'd seen some of the stuff in the geophysical literature. They publish pretty regularly about it, but there's, it just floats them until you actually have a reason to stare at it. But I was at a workshop last August in Colorado on what was called IQ Earth. The SEG's got another initiative. They're actually given $5 million from Statoil to spend over 5 years trying to improve the way that interpretation is done in the oil and gas industry. So a company thought that much about it and thought enough about the SEG that they said, okay, here's some money, figure out some things that are actually going to help us as an industry. And they didn't care. This is all obviously pre-competitive. If one company puts that much money out there in a public professional society, it's pretty impressive. But one of the things that came out of that meeting was that the oil industry has an enormous problem with finding suitable test areas. And this is in part because increasingly they're not just out to find something. They're out there to find and exploit it. And they have much greater interest in what you'd call 4D character of deposits than we probably do. Because they're actually, when they pump fluids out, they put other fluids in, they put other material, slurries in, and the rest of it. Sometimes it gets out of control, like in the Gulf of Mexico a few years ago. But they don't actually have enough places they can go try new things out. And so the role of a synthetic models rose up as a very strategic objective on the part of all of those companies, is to have places they can try out new techniques. And it's a very, when Yago said it'd take a long time to build the model. If any of you spotted, I think it was about his third slide from the end, it's a 220 terabyte data set. 220 terabyte data set. They can actually do downhole logging with the same precision as the real world in that environment. I mean, it's like the Star Trek holodeck down to sort of the molecular level. This stuff is really incredible. And they say, well, hey, in minerals, man, we don't need that. We can't afford it. We can't. But you look at the cost of contributors. I think it was $60K per year. The new initiative in Canada with the Seismic footprints, it's $50K. We do have money out there. But the thing is, what we needed, and I've been talking with Yago and trying to broaden the discussion within the minerals community. Is there a role for this going forward? Do we actually have the need going undercover where we have a lot fewer test sites to do simulations? And one of the other things I think the oil industry has a much better control over, they know what their acquisition technology is doing. In minerals, we really rely on the technical competency and the professionalism of the service industry to provide equipment, which then we get the primary data from. There's very few mining companies anymore. I mean, 30, 40 years ago, and there's still a few, build their own equipment and have the intimate knowledge of how that equipment works. By and large, I would say it's a pig in a poke, but the companies, the service companies, regard a large part of that as their intellectual property and their competitive advantage. And they actually don't tell us what a modeling person would need to know to do a proper simulation. Whereas in the seismic industry and the oil and gas industry, they had those discussions a long time ago. And I don't think there's much that the Schlumbergers or Halliburtons or the CGGs have when they go out and do a survey that they haven't told Chevron. Because Chevron probably won't do a survey unless they know exactly what's going on with their acquisition system. We just, in the minerals industry, we just don't have the questions or the stroke to ask those sorts of questions. And so that's one of the things SEAM might be a little ahead of the curve, and I've told Yagwa that at least we should be having a discussion to see if there's potentially a role, going forward, but it might not be right now. One project that had kind of SEAM-like smell to it a few years ago, well, actually 2001, the first phase, a series of synthetic models were commissioned by a number of mining companies through the Camiro Group in Canada. John McGaughey, president of MIRA, represents the group that actually did the work. They ran gravity gradiometer models here, pretty prescient. I mean, Falcon had only been out there for 2 years at that point, on a variety of deposit styles. And then they went back to the same set of models in 2005 and ran the IP response. So this is kind of has a minerals type SEAM smell to it. Here's an example of that. So they actually, this is from what the SEAM models type were. This would be, I won't call it a dot in the map, but this is a very deposit-specific thing. But as now we start to go undercover, we're talking about mineral systems. We have to broaden this out, probably by at least an order of magnitude. But as to say, this is at least a starting point, because if you say, well, what does that blue unit on top do, 10 kilometers that way and that way? Well, it's still a blue unit, We probably don't have too much control. But maybe we have to start thinking, as John said yesterday in his talk, we can maybe populate that with a little bit of information, maybe from some aeromag data or whatever, some regional gravity. We can take a stab at putting this in a regional context, which would be great. I showed this model before. Obviously, a lot of time and effort went into this. And I think there's with the Footprints program in Canada starting up, I think each of the 3 major test sites, this should be maybe one of the objectives as part of both for interrogating new techniques, as a learning platform for future explorers. I think maybe it would come out. It was, like a lot of things, these things get built, but then they actually don't get, you ask even people who fund it, are you aware that this exists, that you paid for this? And they say, what is that? They don't really know. There's so much data, so many solutions, so much complexity that most mortals don't have the opportunity. That's one of the I won't say Achilles heel in the minerals business. A large part of what I see the SEAM group gets supported by is the research groups in the oil companies, and those do not exist in minerals anymore. We're going to have to rely a lot more on governments. I think universities, it's always pay as you go. The governments ultimately, they have the custodian of the mineral resources for the benefit of their community, their larger community. And somehow I think if the minerals SEAM activity takes off, or is going to be used more formally, it's probably going to have some anchor inside government activities, because minerals companies right now are probably unlikely to be able to stand alone on it. There's the deposits that the Footprints program in Canada just got kicked off. Post-PDAC, they've got something like 15 universities, approximately 50 professors, and it'll be hundreds of students, and a great number of mining companies providing direct support, and a large number of service companies providing in-kind support. And here's the bullet points. I mean, Yagwa had them earlier. Exploration planning and targeting, synthetic and predictive, tactical, real-time data analysis, educational. Going forward, that's one of the things I think, if you get involved in any of the mentoring discussions going on now, there's a lot of knowledge that people of my generation have, but we don't really have the means to sit around the campfire and pass those messages on to the younger people, but we may be able to put some of that in these knowledge we can put into these models. That may be the best way. The case histories, that may be the only way many of us will be able to communicate for a message that 10 or 20 years down the road might be useful to somebody. Because I'll tell you, buddy, we're not going to be around to have those conversations, I don't think. So anyways, I'll just, this one, I just say the layers, obviously there's a density, a connectivity, and a velocity model. All went up into this. This all gets kind of squished like a rose in a book, but it's implicit that that's all part of the story. As I mentioned, highly dependent on internal R&D, and it's not a reason not to do it, but I think we just, you know, we can't just replicate it on the Xerox machine in the same way the oil and gas companies have done it. That's going to have to probably have a heavy role from the service components to provide the actual technology service, and then the cost, or we're going to have to be creative in the cost-sharing mechanism. So with that, if you've got any questions for Yagwa on his presentation, otherwise, say we're just coming up to noon. It's all going to be in the lunchroom there, and say we'll open this. We've got a couple of minutes before lunch. Kim.
Ken, seeing as how you took the cap off the journey about funding models, something I've been thinking about for a while is how I, as a little old consultant, get into these things, and I'm not going to put in 50 grand to a project or 90 grand to UBC a year, but I would be easily put in 10 grand a year to the right project, and I'm wondering if, I know having 100 people at the table is going to make it like herding cats, but perhaps the funding model people could look at would be to have an affordable fee for a seat at the table, and for the diminishing number of majors that there are, they could buy more than one seat.
So votes by representation.
Yeah, or heading by representation.
Andy. Sorry.
I just wondered, I mean, those of us who have been in the mineral exploration for some years, we would have all come across seismic applications within the minerals industry, and has thought been given to an inventory of applications around the world as a starting point for consideration of where you go from here? I'm thinking of, for example, in the bushveld in South Africa, where seismics are pretty routinely applied, in the Witwatersrand Basin, for example, in the coal industry, just a few that I'm familiar with.
I sense that's more of like an inventory of past applications, just so that people can be aware of the various terrains that it's been applied. Is that the spin?
If you're trying to figure out how you're going to advance the whole application, surely a starting point would be to see what the state of knowledge, what the state of the art in the minerals industry at the present point is.
But the SEAM story here in minerals was not just to support seismic. It's the whole gamut of physical properties that I had on the toolkit list to populate that into these models. And that's one of the things that, although again, groups like MIRA have tried quite hard to put petrophysical databases together, compared with the oil industry, we're way behind in terms of characterizing. And sometimes we just shrug and say our world is too heterogeneous. Alteration is too much of an overprint to make a sensible go of it. But the oil industry has committed, both from exploration and a geotechnical perspective, a huge amount of money in understanding the petrophysics of things, not just to correct velocities when they're doing migration in the early stages of the seismic processing. And those models, however we create them for susceptibility, connectivity, and density, are going to require some real thought and a lot of effort to put something sensible together. So I guess that might... Did I see a hand? Anyways, that... Des.
Yeah, I just want to echo what Ken's mentioning. I want the whole thing is primarily about non-seismic. If there is a seismic component, especially the 3D seismic is increasingly used in mineral exploration, then that will be naturally fitting in. So, yeah, we'll make sure. Thanks for the comment. Seeing mineral is not about seismic. It's could include part of seismic, but more broader array method. Yeah. And other part of the heterogeneity physical property, actually, I don't want also the level of complexity of the seismic exploration is actually it's no less than what we face in mineral exploration. If you look at one of those 4 models, for example, thrust or foothills, it's just as complex as what we face. So.
Des had a comment.
Yeah, I do. It's a sort of like an observation and also something to dwell on. The oil industry, and especially in the States, and this phenomenon of how they've actually responded by cooperating after such a long time of cutting each other's throats, and then you know, who owns the data and all that. It's such a different situation over there compared to Australia, and that's not sort of being factored into the thinking at the stage. So, in the sense that there is now a common Gulf of Mexico model that everyone's contributed to, that's great. But it's taken a hell of a long time to get to that point. And interestingly, just in case everyone doesn't know it, Schlumberger have created a sort of competitor model to this for their own training. And where did they go to get it? They came to Australia, because Australia is the only place that makes their data free and you know, without any restrictions. And so the Gippsland 3D or 4D modelling of Gippsland is now features, that's front and centre of how Schlumberger teach all their products and train all their students in Petramod and all the rest of it. So interestingly, there's a competitor to SEAM through the vendors, and Schlumberger is big enough to do whatever they feel like, as we well know, and that's what they've done. You could say it's in response, you could say it's not, but it's happened.
Yes, I would actually beg to differ. I don't think it's competitive. I don't think it's a competing model. It's for entirely different purpose, for different approach from the SEAM. It's just not in the same league. And similar thing, I mean, I'd see in the mineral industry, there are a whole bunch of things going on, and that's not to see. Yeah. It's kind of competing with this. Eventually, a lot of this, actually, what we see is happening collaboratively. And
well, I mean, it's happening. So whether it's competing or not, it's just happening. And I think my other point was bringing it back to the mineral situation and the debate of today, where in Australia, we want to, you know, in this forum, we should be perhaps biasing the objectives to come up with something that works in the Australian context, I would think. I know we've got Canada and the US trying to mould the agenda, but it's up to us to come up with an Australian push, I would think.
Again, I would say the whole effort is seen from get-go. It's global. And in fact, I would, Ken had that meeting missed, but that's whole things about the global mineral council meeting about it. So, I don't think restricting it to a specific geographic region is really a good idea. I don't think it will help.
Well, you know the list of players that he had up there. They're all global players. I mean, BHP's domiciled here, and they're participants. So, I mean, Des, it's hard to know what color the flag is too often. I mean, one of the things that I was surprised that on the land stuff, all of those companies you're mentioning about wouldn't have cooperated before. They all supported a land seam, and to my knowledge, they abandoned onshore exploration 20 years ago. You know, they're all been focusing on offshore, but they thought enough of the program to actually put some money into and the amount of money was chump change. I mean, if Schlumberger, the real cost is going to be implementation into your group. So going and getting a data set from Queensland, you know, maybe with some different variety or different focus, as Yog was saying, I'd say it's really not the cost of the participation in SEAM. They probably are getting access to SEAM either through their own, if they're a sponsor, or through their clients. You know, their clients are the ones that sponsor this, and they would say probably you have to, you know, we're going to give you access to the SEAM model. Now, Ian McLeod was at the PDAC meeting, and he said there are some problems with access of the results. He said from a point of view of a service company, it was a bit awkward. And I won't say he was quite anti-SEAM, but seamless? Anyways. So, yeah, anyways, it's, I think we can probably chop it off there and go get some lunch, and we can hold some thoughts. Oh, Ned.
I just had one comment. Now, as I understand it, this is about creating very detailed forward models that researchers can then use those data sets to test their inversions. Is that correct?
Or, test a new geophysical technique. That's right.
I think
a simulation.
My point is, in the minerals game, aren't we putting the cart in front of the horse in that, yes, the petroleum industry have been collecting fantastic physical properties information for over 100 years. I don't know of a single resource project I've ever been near where once you step 10 metres away from the ore body, they know anything about densities or mag susses. So are we actually going to just create fantasy models that could do more harm than good?
Well, John McGaughey, I won't speak explicitly for him, but he touched on this yesterday in building regional models without a great deal of background information, including petrophysics. And I think there are efforts there. I touched on it, and I said, really, that blue unit there, we don't really know what's happening to it 10 kilometers away, but start off making, as we often do, some simple assumptions and just say, maybe there's some regional folding or some thrusting, we can put that in, we can simulate that. But we know what the sweet spots are in our mineral systems, and the alteration zones. The Lowland-Gilbert model, we can take that, we can populate that with some sensible physical properties that probably on bulk are reasonable. So I think we can take a stab at it. I don't think it's quite, because we're never going to get that physical property information on those historic deposits. It's a given. We can encourage people to become more diligent going forward, but I don't think it's the reason to wait. I don't think it should be a linear process, that we have a 20-year campaign of acquiring physical property data, and then we start building these models.
But I would argue that that's the attitude we always take to physical properties. Oh, somebody else can do it, I'm going to do the fun stuff, and that's why we're here.
Actually, Ned, I really appreciate that comment. That actually might be the direction the phase 3 can go. Instead of assume all this is not available, build a model. Let's actually make the collection organization analysis of the physical data as an integral component of a SEAM. That if that's actually what serves the community, then that's actually what we can do. So, John?
Just one quick question on the SEAM. Were those models based on actual geological models and real data as a starting point, at least, or are they completely synthetic?
Yes, bulk of those are from real geologic scenario. People, different companies contributed in, and a lot of those were actually done by exploration geophysicists and petroleum geologists. So it's not kind of put out in there.
And when the project got going, was it hard to come to agreement on what data set to start with, what geological model was broadly of interest to all the contributors?
Yeah, as I mentioned initially, there were a lot of debate, but I think the management committee, because represented from all the sponsors, got together, finally hammered things out. I think that's how it will work out if we ever put mineral together, because it's either you do or you just squabble and for years nothing happens. Other thing I will mention is about the smaller companies and contractors. The way it's now structured is that the sponsors would get the model data as it goes, and what's scoped out in the initial project will be delivered to sponsors. Then there are additional simulation or model component. Then the sponsors actually also have to pay to get them, and also the general community would have to access data on a pay basis. The university groups have reduced rates. So all this actually been discussed, formulated. So a lot of those, in fact, as far as import goes, the science and data is one aspect, but how to make this work for mineral exploration community should also be part of the discussion. So we would love to hear the comment on that.
Okay, we'll get one more and then we're going to break for lunch.
Excuse me. I know it's lunchtime, so I'll keep it pretty quick. I'm a bit confused about SEAM. I'm a geologist. Ken, you mentioned up there on one of your slides half a dozen or so deposits around the world with which the SEAM approach has been adopted by different companies. What actually happened and what does it mean for those companies in terms of their exploration?
You're talking about the synthetic models I showed?
I'm talking about Red Dog and Gamsberg.
Okay, right. Well, I mean, as normal, the people with money came to Camiro, which is like Amira here in Australia, and said, we'd like to have some models run on some real deposits, which we'll give you the geology for, and a couple of synthetic ones. Camiro found Mira, agreed to do the work, I guess tendered a quote, and it was accepted. The work was done, the report was presented. Nature of Camiro, like Amira, eventually that becomes open file, public domain, the first phase, and then later the IP, done, private, proprietary for a period of time, and open file. I have not seen anybody use those results outside the companies who may or may not have done it, but they don't have to articulate that in public. I have not seen them surface in any application or publication that I've seen. The Noranda model is a little bit different. It was done, I believe, by Noranda, maybe with Mira's help. It was used at the time when they had a major program in the Abitibi, so it wasn't a passive model. I think there was probably a fair bit of use made of it, but it was all internal to Noranda Xstrata at the time. And then UBC picked it up for a specific application testing a new geophysical technology. They did a forward model of that. They didn't do inversion, they did a forward model of that. So, you know, it's often in the case of the industry, if you ask people, you sit around a room, they say, man, do you remember those Camiro models? And maybe 2 or 3 old farts will say, yeah, I remember those, yeah. But that's often what a lot of the research work happens to it, is that it disappears onto the library bookshelves of companies who then get rid of all the people that knew about it. They go off into the private sector and, you know, become consultants. They may draw upon it, but there's no obligation for them to release the information. So my point was, we've kind of done sort of SEAM-type activities in the past, but it's not been pulled together in a cohesive way, particularly with a focus to now looking at undercover initiatives, or in the case of Canada, and the footprint initiative, and it starts to show some of the deficiencies, like Des mentioned, in Yagua, the issue of petrophysics. We're kind of, we sit behind, what do we do about that? Ned's concerned about it. The cost, you know, who's going to deploy it, you know, Kim's concerns about, okay, a lot of the technology gets developed by those with the money, but they're often reliant on people like Kim and others in the room to actually be the hands and the arms and the brains to use it. So the oil industry's deployment model is very different. You look at Chevron, and you know, they've probably got more people in their research group than were attended this meeting at the ASEG, right? One company. So they work at a very different level in terms of how they'd ultimately use it. So I don't saying we should clone SEAM, but there's aspects of it which I think would be helpful for the reasons that Yagua and I tried to touch on.